In this class, now I am going to explain circles. So first let us see the definition of circle. A locus of point which moves equidistantly from a fixed point is known as a circle. See, on this plane, observe all this group of points or locus point. All these points are moving from a fixed point which maintains a fixed distance is known as a circle. Locus of point which moves equidistantly from a fixed point is known as a circle. See here, I have taken group of points. All these are moving equidistantly from this fixed point. That fixed point is known as center of the circle. Let it be O. And that fixed distance is known as radius of the circle. So, suppose if this radius is equal to 0, then that is known as a point circle. If radius is equal to 1, then that is known as a unit circle. So, suppose if this R is positive, then that is known as a real circle. If R is negative, then that is known as imaginary circle. Observe that. Next, let us go to derive the algebraic equation of this circle. So for that, we need to assume the center of the circle as h comma k, and this locus point you have to consider as x comma y, because this is a variable point, locus point. It can be taken anywhere on the circumference of the circle. So as you know, in that figure OP equal to R. Now determine the distance from O to P. Square root of x minus h whole square plus y minus k whole square, which is equal to R. Now square on both sides, x minus h whole square plus y minus k whole square, which is equal to R square. So this is known as equation of the circle when the center of the circle and the radius is given. So suppose if we simplify that previous equation, x minus h whole square plus y minus k whole square equal to R square, we will get in this form: x square plus y square plus 2gx plus 2fy plus c equal to 0. On simplifying the previous one, we get this one, where g, f, c constants, numericals, which belongs to real numbers, where x comma y is locus point. So you know standard form of second degree equation: ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0. So this equation represents a circle if and only if coefficient of x square is equal to coefficient of y square. Next one, this xy term coefficient must be equal to 0, h must be equal to 0. And the third one, g square plus f square minus ac by mod a greater than or equal to 0. And the fourth one, discriminant value of this second degree equation should not be equal to 0. That is delta. Delta is equal to abc plus 2fgh minus af square minus bg square minus ch square. This is known as a discriminant value of this second degree equation. So for the circles, this delta should not be equal to 0. This represents a circle equation if and only if it has to satisfy this many conditions. So in the next step, In place of h, I am going to take 0 because we are discussing circles. So here I am writing h equal to 0 and I am writing coefficient of x square equal to coefficient of y square. See here, ax square. If you write here it is 0, then okay, it becomes 0 if you take h is equal to 0 and put b equal to a. Here ay square plus 2gx plus 2fy plus c equal to 0. In the next step, I am going to divide both sides with small a. Why? To make x square y square coefficient as 1. In the next step, here x square plus y square plus 2 g by a x plus 2 f by a y plus c by a is equal to 0. See what I am going to do in the next step. Here I am writing x square. Here 2 into g by a into x. Here I am adding wantedly g by a whole square left side of the equal symbol. At the same time I will take g by a whole square in the right side of the equal symbol also. See here, write here y square plus 2 into y into f by a whole square. So here c by a, transfer this one to the right side. So here what I have taken g by a whole square left side of the equal symbol, no, at the same time it should be written in the right side of the equal symbol. G by a whole square, here f by a whole square. So in the next step, see, so from here to here it can be written as x plus g by a whole square, and here this one, here 2 into y into f by a plus add here f by a whole square left side and right side. So from here to here it can be written as x plus f by a whole square. Now simplify the RHS. So on simplifying we get like this, g square plus f square minus ac by a square. See, this one I am going to write x minus g by a whole square plus, this is y, no, y minus f by a whole square. So here this one, see how I am writing, g square plus f square minus ac by mod a whole square. Why I have transformed that ax square plus ay square plus 2gx plus 2fy plus c equal to 0 means, see, to get center and a radius of that circle. So when the center and radius is given, so before this we wrote this circle equation, x minus h whole square plus y minus k whole square equal to r square. Now compare this equation with this, so that what do we get for h comma k? Minus g by a comma minus f by a. So this is the coordinates of center of the circle. And here in the place of r, root of g square plus f square minus ac by mod a. Okay students, right. Suppose if the circle equation is given like this, x square plus y square plus 2gx plus 2fy plus c equal to 0. Now in the place of a, x square y square coefficient, in the place of a I have taken 1. If you write a equal to 1, then that center will become, so in the previous one minus g by a we got, no, only minus g will come, because in the place of a we are writing 1, here minus f, this is the center, and a radius, in the previous formula put a equal to 1, so that we will get a radius as g square plus f square minus c. Okay, So in the next step, so suppose extremes of the diameter of a circle are given. In such case, how do you determine the equation of a circle? See here, this is circle. So in this circle, what are given to us? Extremes of the circle or end points of the circle, x1 comma y1, and other end point x2 comma y2. Now extremes or end points of the diameter of a circle are given, and they are asking us to find equation of this circle. How do we find? As you know, circle is nothing but a locus. Okay, so let us take that locus point anywhere on the circumference of the circle. Shall I take x comma y over here? You can. Right. Now connect this PA and PB. You know, this is one semicircle. So angle in a semicircle is 90 degrees. You read that degree measure theorem in the plane geometry circles. As per that theorem, angle in a semicircle is 90 degrees. So here PA is one of the chord. Let us take whose slope is M1. PB is one more chord. Let us take whose slope is M2. Now find M1. Difference of y coordinates by difference of x coordinates. Y minus y1 by x minus x1. Go to that chord. Difference of y coordinates. Y minus y2 by x minus x2. As you know, these two chords are perpendicular to each other. Hence, m1 into m2 is equal to minus 1. Now write here y minus y1 by x minus x1 into y minus y2 by x minus x2, which is equal to minus 1. Now simplify this. On simplifying this, so you will get x minus x1 into x minus x2 plus y minus y1 into y minus y2, which is equal to 0. So this formula we have to apply to get the equation of this circle when the extremes of the diameters are given. Right? Next, see the formula x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equal to 0. Right? See one question. Find the equation of a circle. Find the equation of a circle. See, ax plus by plus c equal to 0. It is a one line moving on the plane like this. It is intersecting x-axis at A and y-axis at B. Now find the equation of circumcircle of the triangle formed by this line with coordinate axis. What is the question? Find the equation of circumcircle of a triangle formed by this line with coordinate axis. See, line is moving like this. Okay, so with coordinate axis, here this line is making a triangle, that is AOB in this figure. Now we want this circle equation. For AOB triangle, this is a circumcircle, no? So here what kind of triangle AOB here? A right angle triangle. So right angle is formed at origin. Okay, hence, so this line will be the diameter for this circle. Am I right? Because see here, so here for this circle, so here angle in a semicircle, here it is making angle 90, no? Hence this hypotenuse will be the diameter for this circle. Okay, now here identify the end points of this diameter. So A is there on the x-axis. Now put y value 0. If you put y value 0, your respect to x value minus c by a. If you put here x value 0, if you write here x value 0, your respect to y value minus c by b. Now here we identify the extremes of diameter of this circle. You know, just now we learnt equation of a circle when the extremes of the diameter of the circle are given. Apply that. So on applying that, here let it be x1 y1, x2 y2. So x minus x1, here x plus c by a, and x minus 0 plus y minus y1, y minus y2 plus c by a b, which is equal to 0 we will get. Now simplify this. So if we simplify, here x square, here y into y square, here c by ax plus here c by b into y, which is equal to 0 we will get, because this is passing through the origin, hence constant term will not come. Right. Next. So suppose 3 points are given. Okay, that 3 are non-collinear points. Let us take that 3 points as a x1 comma y1, b x2 comma y2, c x3 comma y3. Okay, from these 3 non-collinear points we can able to draw one circle only. Okay, now determine that circle equation. How do we find the equation of the circle which is passing through these 3 points? Observe that 3 points are not collinear. So there are 3 or 4 methods, but okay, so 1 or 2 methods I explain you. See here, let us consider our required circle equation be x square plus y square plus 2gx plus 2fy plus c equal to 0. This is passing through A. Hence, in this equation, replace x, y by this point. You will get one equation in terms of A, B, C. Keep it aside. And go to the second point. Substitute that second point over here. Again, you will generate one more equation in terms of GFC. Again, go to the third point. Substitute that third point over here, and you will get one more equation. So 3 equations we got in terms of GFC. So you know how to solve that 3 equations and solve them so that we will get GFC and come back. So in the place of GFC, write those 3 values so that we will get our required circle equation. This is one of the method. And see one more method, that is called a determinant method. See, first write here determinant of x1, x2, x3, y1, y2, y3. Write here 1, 1, 1 into x square plus y square plus determinant of c1, c2, c3. Here y1, y2, y3. 1, 1, 1 into x plus determinant of x1, x2, x3. And here c1, c2, c3. 1, 1, 1 into y plus x1, x2, x3, y1, y2, y3, c1, c2, c3 is equal to 0, where ci is equal to minus of x1 square plus xi square plus yi square. Here I runs from 1, 2, 3. This formula we have to apply to find equation of that circle passing through x1 y1 and x2 y2 and x3 y3. See here, see the formula. Here x square y square coefficient should be this. On finding the 3 by 3 determinant, so we will get some constant into x square plus y square. This into x and this into y, and this is going to be some constant. Here what you have to take for C1, C2, C3? So C1 will come from this x1 square plus y1 square. Suppose if you write I equal to 1, here it becomes x1 square plus y1 square. That is C1. Write I equal to 2, you will get C2. Write I equal to 3, you will get C3. You have x1 y1, x2 y2, x3 y3 in the problem. Okay. Next. You know the meaning of concentric circles. What kind of circles are known as concentric circles? Circles having the same center are known as concentric circles. So, okay, we will get some application based on these concentric circles also. Okay, so here circles having the same center. Here let us take center V, h comma k, radius r, capital R. So whose equations will be x minus h whole square plus y minus k whole square is equal to r square, one circle equation, and other one x minus h whole square plus y minus k whole square, which is equal to capital R square. Just the difference we will identify in the place of radius only. Now let us go to the meaning of concyclic points. What are meant by concyclic points? Points lying on the same circle are known as concyclic points. Okay, so based on this also we get some applications. So 4 points will be given to you. So in any one of that 4 points, they will miss either x or y coordinate, and they will ask you to find that unknown value. These 4 points are collinear, then find that unknown value. So in such case, what you people have to do? Find the equation of a circle passing through 3 points and get the equation of the circle and substitute the 4th point in that circle equation so that you will get that unknown value. Right. Next, here we have some important point related to that concyclic points. Okay. See, observe that. There are 2 lines which are passing like this. Let us take whose equations a1x plus b1y plus c1 equal to 0, and this line equation a2x plus b2y plus c2 equal to 0. These 2 lines are intersecting x-axis at A, y-axis at B, and x-axis at C, y-axis at D. Now my question is, okay, if these 4 points are concyclic, these points are concyclic means those 4 should be lying on the same circle. If these 4 are lying on the same circle, then we get this condition a1 a2 is equal to b1 b2. Just you remember like a standard result. Okay, so these are the 2 line equations which are intersecting x-axis and y-axis at these 4 points. Then if these 4 points are concyclic, means lying on the same circle, then we will get this a1 a2 equal to b1 b2. Remember like a standard result, because so among this a1 b1 a2 b2 4, so 3 numericals will be given to you, one unknown value they will write, and they will ask you to find that, use this relation and find that unknown value. So and also find the equation of this circle which is passing through these 4 points. So you can use this method to find the equation of this circle. See here, just you take the product of these two line equations, a1x plus b1y plus c1 into a2x plus b2y plus c2 minus, see here, minus a1 b2 plus a2 b1 xy, which is equal to 0. See, what did I do? Just I took the product of these two line equations and I subtracted here this quantity, because on multiplying this here xy term will be generated. So you know, in the circle equation xy term will not come, that I have subtracted. Okay, right. Next, let us go to power of a point with respect to the circle, and before that let us see some notations related to these circles. Okay, so you know, here equation of the circle when center and radius is given. So suppose if the center is kept at origin, then how do you get such circle? 0, 0. If you take center is 0, 0, then it will become x square plus y square equal to r square we will get. Okay, this is one more standard form of the circle equation, x square plus y square equal to r square, whose center is kept at origin. Now let us see some notations related to this circle. So you know, x square plus y square plus 2gx plus 2fy plus c equal to 0. In most of the applications we will get a circle equation either this form or x square plus y square equal to r square. In these two forms only we will get. So this left side expression must be taken as s, x square plus y square plus 2gx plus 2fy plus c. Now 2 points are given. 2 points. Let us take 2 points, x1 comma y1 and other point x2 comma y2. Suppose if you want, see here, s1 means here the second degree term should be written as xx1. This y square also should be written as yy1. Here x coefficient to 2g is there, no? Take half of it, g of x plus x1 plus take half of it, fy plus y1 plus c. So this is s1. Suppose if you want s2, what you have to do? Replace x1 y1 by x2 y2. That's it. So that you will get s2. xx2 plus yy2 plus g of x plus x2 plus f of y plus y2 plus c. That is s2. And next s11, s11. This is very important. Directly this point should be substituted in the place of x and y. See here, x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. This is s11. Okay. Suppose s12 if you want, what you have to do? So in this, so here you have to write like this, x1 x2 plus y1 y2 plus g of x1 plus x2 plus f of y1 plus y2 plus c. Okay, so these are the notations of this circle with respect to this p and q. So here s have taken left side of this equal symbol. So if RHS any terms are given, so make sure that transfer the right side terms to the left side, so that we can make RHS as 0. After making RHS as 0, left side must be taken as s. Okay, next S1, S2, S12, S1, S11, S12 and S2 also you know how to write. Suppose if the circle equation is given in this form, x square plus y square is equal to r square. If it is given like this, then what you have to do? Transfer this one to the left side. X square plus y square minus r square is equal to 0. This left side must be taken as s. X square plus y square minus r square. Now what is s1 for this? X1 plus y1 minus r square. S11 x1 square plus y1 square minus r square. Okay? Right. If you want S2, xx2 plus yy2 minus r square. S12, x1 x2 plus y1 y2 minus r square. Next, let us go to the position of a point with respect to the circle. Okay, tell me. See here, this is a plane. On the plane, infinitely many points you can write. Okay, so if you write a circle, so this circle divides this plane into three set of points of this plane into three disjoint sets. Some points which belongs to the interior portion and some points outside, some points lying on the circle. Okay, now circle equation is given s equal to 0. One point p x1 y1 is given. Whether it is there interior or outside of the circle or on the circle, how do you say means? Tell me students, this is the center. Okay, let us take center with O. One point P is given. Either it may be here or here, it may be on the circle or it may be inside of the circle. How do you say? So there is one procedure. Okay, when the equation of the circle is given, how to determine the center you know. Okay, what is the center formula? Minus g comma minus f. And how to determine the radius of the circle also you know. Find the radius of the circle. Okay, next measure the distance from O to P. If OP is more than radius, then point will be outside. If OP is less than R, point will be inside. If OP is equal to R, then point will be lying on the circle. Point P coordinates will be given to you, circle equation will be given to you, and they will question us to identify whether P is there outside or on the or inside. Means what you have to do? Find the center, find the radius. Measure this. OP length, you know distance between the 2 points, and radius you know. So, okay, when OP, this length is more than the radius, then P will be outside. If OP is less than R, P will be inside. If OP equal to R, P will be on the circle. Okay, so if you take square on both sides, here if you take square on both sides, here what do you get? OP square, which is equal to R square. Okay, so this OP square minus R square is called power of a point with respect to the circle. Power of a point with respect to a circle s equal to 0. So bring a R square equal to left side. OP square minus R square you will get, which is equal to 0. OP square R square is nothing but, if you simplify Amma, then you will get S11. Take any circle and simplify this relation OP square minus R square, so that you will get S11. Okay, you know S11 notation. So here S11, if a point is there on the circle, S11 will become 0. Here also square on both sides, OP square minus R square greater than 0 will come. S11 greater than 0 means point P is there outside. And for this, OP square minus R square less than 0, S11 less than 0. Okay, here what I have explained, power of a point with respect to the circle. One point is given and they will question you to find power of that point with respect to the circle. So then what you people have to do? You have to find simply S11. What is the power? OP square minus R square. S11 means you will get some numerical that may be positive or negative or equal to 0. Suppose if P is there outside, then your S11 will be positive. If you P is there inside, S11 is negative. If P is there on the circle, S11 is equal to 0. Okay, so this is called power of a point with respect to the circle or position of a point with respect to the circle. If S11 is positive, point should be outside. S11 equal to 0, point is there on the circumference of a circle. If S11 less than 0, point is there inside of the circle. Right. Next. Okay. So, see, find the x-intercept made by the circle x square plus y square plus 2gx plus 2fy plus c equal to 0. Next question is what? Find the x-intercept made by x square plus y square plus 2gx plus 2fy plus c equal to 0. Now see this. X dash, y dash. Now this is rough diagram. Circle is moving like this. It is making some x-intercept, no? So here the distance from A to B, this is the portion which is made by the circle on the x-axis. Okay, so this is called x-intercept made by the circle. How much is this? Okay, see here, how do we find this? Let us consider A coordinates be 0, x1, B coordinates be x2, 0, because A and B are there on the x-axis and whose y coordinates will be 0. If you put y equal to 0 in this, so then it will become x square plus 2gx plus c is equal to 0. Now solve this by quadratic formula so that you will get x equal to minus 2g plus or minus root of b square minus 4ac by 2a. So take 4 common and cancel with the denominator. Here you will get minus g plus or minus root of g square minus c. Now if you consider plus, you will get one value for x, that is x2. If you take minus, you will get one more value for x, that is x1. Now you know the distance from origin to B is x2. The distance from origin to A, x1. You want AB. AB means how do you get? Difference of x2 minus x1. x2 minus x1. Okay, now x2 means plus, x1 means minus. Simplify that. You will get 2 into root of g square minus c units. 2 into root of g square minus c. What is the x-intercept made by the circle? So this length A to B, 2 into root of g square minus c. Similarly, what is the y-intercept made by the same circle? Y-intercept. See here. This is the y-intercept made by that circle. So same, on the y-axis x value becomes 0. So that in the place of x, if you write 0, you will get one quadratic equation in terms of y and solve it and follow the previous procedure so that you will get this y-intercept as 2 into root of f square minus c. So suppose if the circle touches x-axis, then x-intercept made by this circle becomes 0, no? So 2 into root of g square minus c equal to 0. Simplify. You will get g square equal to c. And if the circle touches only y-axis, then here also y-intercept made by that circle becomes 0. Simplify. F square is equal to c you will get. Now, suppose if the circle touches both the circle, touching both the axis, x-axis as well as y-axis. In this case, g square equal to c and f square is equal to c you will get. Now g is equal to plus or minus root c and f is equal to plus or minus root c. Okay, and go back and substitute in this circle equation. X square plus y square plus 2 into g value, here plus or minus root c, x plus or minus 2 root c, y plus c, which is equal to 0. Okay, that circle may touches both the axes in the first quadrant or second or third or fourth. Okay, na? Right. Next, see, suppose, see here. Okay, here find the equation of a circle whose center is alpha comma beta and touching x-axis. Find the equation of a circle whose center is given as alpha comma beta and touching x-axis. Means how do you find whose equation? Center is given but radius is not given. But radius you will get from this diagram. This is the radius now, that is nothing but beta. Center is given, we wrote the radius. When you have the center and radius, how to determine this circle equation you know. X minus alpha whole square, y minus beta whole square, which is equal to beta square. Similarly, okay, if the center is given and if it is touching the y-axis, here like this, center is given and they said that touching y-axis means this length will be alpha. Now only center is given and they said that it is touching the y-axis, so that we got the radius as alpha. Okay, because the distance from here to here it is alpha. Means radius is known to us and center is known to us. Then apply the formula x minus alpha whole square and y minus beta whole square, which is equal to alpha square. Next, find the equation of a circle whose center is lying, passing through the origin, and center is lying on the x-axis. What is this equation of a circle passing through origin and center is lying on x-axis? Means, so this will be the radius and center is alpha comma 0. Now apply x minus alpha whole square, y minus 0 whole square, y square, which is equal to alpha square. Similarly, equation of a circle passing through the origin and center is lying on the y-axis. Here 0 comma alpha. Now radius is alpha. Now x minus 0, x square and y minus alpha whole square, which is equal to alpha square. Now see the next two. Equation of a circle touching x-axis at alpha comma 0, and making 2L y-intercept. Okay, this is the equation of a circle touching x-axis at alpha comma 0 and making 2L y-intercept. This length is 2L. How do you find this circle equation? See, okay, so they said that it is touching x-axis at alpha comma 0, and this y-intercept is given as 2l units. Means how do you find the circle equation? See, identify the center. The distance from here to here, it is alpha, no? Hence the center x coordinate will be alpha. So this length is given 2l. Now drop a perpendicular from center to this chord. If you drop, it will meet the midpoint of this chord. Chord length is 2l. So this will be L, this will be L. Now this is L. Radius you do not know. Let us take this radius as beta. Now the distance from here to here, it is alpha. Now you know this makes 90 degrees. Apply the Pythagoras theorem so that you will get beta square is equal to alpha square plus L square. Now we want beta. Now beta is equal to root alpha square plus L square. Now radius you got. Okay, because this is beta, no, that is equivalent to this, because this is also radius. If it is taken as beta, then this will be beta. Now y coordinate of the center is beta. Now you got the center, now you got the radius. Now apply this formula. X minus alpha whole square plus y minus beta whole square, which is equal to beta square. In the place of beta, write this result. I think we have understood this. What is this question? Equation of a circle which touches the x-axis at alpha comma 0 and making 2l units on 2l units as y-intercept. So here what did I do? First I identify the x coordinate of the center, because this length equal to this length. Alpha I wrote. I dropped a perpendicular from center to this chord, which meets midpoint of this chord. You know that total length is 2l, then this will be L. I don't know the radius, I took as beta. So this is L, this is alpha, this is L. Now find beta. Now this length equal to this length, beta. Okay, now you got the radius and y coordinate of center. So center is there with you, radius is there with you. Apply this formula. Next, same model of question, but now the circle is making x-intercept and touching the y-axis. Touching y-axis and making x-intercept as 2k units. Okay, touching y-axis at 0, okay, alpha or beta you can take, no problem, beta. And making how much x-intercept? 2k units. So here what you have to do first? You have to identify the center. How? How? Students, see here. Okay. Here 2k units. Drop a perpendicular. Okay. So this length is how much? K. So this length is how much? Beta. Now you got the y coordinate of beta. X coordinate of y coordinate of center as beta. X coordinate of the center don't know. So this is the x coordinate of the center. Don't know, but let it be alpha. So this length is equal to this length, because both are radi. Now which makes 90 degrees with this chord. Now here one right angle triangle is formed. So here we need to find alpha. Apply the Pythagoras theorem. Alpha square is equal to k square plus beta square. Now prepare alpha from here. Write here alpha. Now here you know the center. Now radius is alpha. Take radius as alpha, center as alpha beta. And determine the circle equation. X minus alpha whole square, y minus beta whole square, which is equal to alpha square. Okay. Right. Next, see here. Let us go to the length of the tangent. See here. This is one exterior point whose coordinates are x1 comma y1. From this point to this circle, How many tangents can we draw? Two tangents. One can be drawn to this side, one more can be drawn to this side. So this is A, this is B. Both lengths are equal. You know that plane geometry property, PA equal to PB. So here equation of the circle is given to you. So when the equation of the circle is given to you, how to determine the center you know, and find the radius. And P is given to you. Center you know how to determine. So measure this length, that is D. Now you know radius makes 90 degrees with the tangent at its point of contact. Apply the Pythagoras theorem. So that you will get length of the tangent root to d square minus r square. Root to d square minus r square is nothing but S11 in this circle. Instead of doing total this procedure, directly you can use that formula, root S11. Okay, you know that S11, length of the tangent. Next, let us go to the parametric form of a point on the circle x square plus y square equal to r square, and x square plus y square plus 2gx plus 2fy plus c is equal to 0 also. So we have circle equation in two forms in this chapter. One is first x square plus y square equal to r square. First let us see the parametric point of a point on this circle. See here. X dash, y dash. Whose center is 0, 0. And here I am taking one locus point over here, x, y. So this is radius. Now draw a perpendicular from this point to the x-axis. This length is x, this length is y. Now this is OP, radius, which is making how much angle at the center? Theta. Take this angle as theta. See here, OP radius. Now rotate like this, rotate like this, rotate like this. If you keep on moving OP, rotating like this in the anti-clockwise direction, you will get different points which are locating on the circumference of the circle. Okay, right. See here, this theta can be either 0 or smaller than 360 degrees. Okay, now OP radius, here you start from here, rotate like this. Okay, if you keep on changing theta, you will get different points which are locating on the circumference of the circle. Now consider this right angle triangle and define cos theta. Adjacent by hypotenuse, x by r. Now x equal to r cos theta. Similarly, define sin theta. Sin theta is equal to y by r. Now y is equal to r sin theta. Now x equal to r cos theta, y equal to r sin theta is the parametric form of a point on this circle, r cos theta, r sin theta, where theta is a parameter. Okay, if you write theta equal to 30 degrees, you will get 1 point, theta equal to 60, you will get 1 point, theta equal to 135, you will get 1 point, theta equal to 270, you will get this point, theta equal to 225, 270 here, 315, like if you keep on changing theta, you will get different points which are locating on the circumference of that circle. Okay, I hope you have understood this parametric form of a point on the circle x square plus y square equal to r square as r cos theta comma r sin theta. Remember that. But if the center of the circle is other than origin, the center of the circle is other than origin, means if the circle equation is given like this, x square plus y square plus 2gx plus 2fy plus c equal to 0. For this circuit, okay, how do you write the parametric equations? This is origin. Now take the rough diagram over here. Whose center is minus g comma minus f. Now identify a point P over here, x comma y. Now the distance for, otherwise let us take the center of the circle be h comma k. H comma k. So the distance from here to here h. The distance from here to here k. Now what is this? Radius of the circle no? R. So here radius from here to here radius and drop a perpendicular. Now I want this length. How much is this? Can you tell me? So consider this angle as theta. This length is how much? From here to here it is x. From here to here it is h. I want this length means subtract this h from this x. So that here you will get this length as x minus h. Similarly from here to here it is k. From here to here it is y. I want this length. So how much is this? From this entire y subtract this k, so that you will get this length as y minus k. Now here one right angle triangle formed. So this is the radius of the circle. Now in this right angle triangle define cos theta. So adjacent by hypotenuse, x minus h by r. Now x equal to h plus r cos theta. Similarly define sin theta, y minus k by r. Now y is equal to k plus r sin theta. So these are the parametric equations of a point on this circle whose center is other than origin, whose center is taken as here h comma k. So you know, if the circle equation is given like this, how to determine the center, how to determine the radius, you know, prepare center and radius and substitute here, so that you will get parametric form of the point on that circle. Okay. Next, see here. Let us go to chord of contact. What is the meaning of chord of contact? Here one point P is there, whose coordinates x1 comma y1. From this point to this circle, we can draw two tangents which are touching the circle at 2 points. Connect this A and B. Okay. So what is formed here? A chord, that is called chord of contact. It is a chord which is formed by joining the points of contacts of tangents drawn from P to this circle. Okay. So suppose if you want this chord of contact equation, that is S1 is equal to 0. S1 equal to 0 is the equation of this chord of contact. Okay. Right. And sometimes they will ask you this length also. Okay. Use this formula, AB length. 2r into root S11 by S11 plus r square. Use this formula to get length of this AB. Your proof is not required. Just answer this question by remembering the standard result. 2r into root S11 by S11 plus r square. When the circle equation is given, how to determine the radius you know, how to prepare S11 you know. Substitute them and simplify so that you will get AB this many units. Okay. And here one triangle is formed. Okay. So sometimes they will ask you to determine area of this PAB triangle also. Okay. So the PAB triangle, area of the PAB triangle, so you will get this much, r into S11 whole power 3 by 2 by S11 plus r square. What is this? Area of triangle PAB. R into S11 whole power 3 by 2 by S11 plus r square. square units. And also here you have to remember one more point. This is circle whose equation is s equal to 0. From exterior point to the circle we can draw two tangents. One is touching at A, one more is at B. This is center. This is radius which makes 90 degrees with a tangent at its point of contact. Now angle between these tangents is theta. Angle between the tangents is theta. Now here this is angular bisector for this angle. Means this angular bisector divides this entire angle into two equal halves. Theta by 2. Here also theta by 2. Now OAP is a right angle triangle, no? So AP length of the tangent root S11 you know. Now remember this relation, tan theta by 2 which is equal to R by root S11. Tan theta by 2 is equal to R by root S11. Okay, opposite here. Define the tangent ratio with respect to this angle. Opposite by adjacent. R by root S11. And if you connect this one also, here one quadrilateral is formed. OAPB. Whose area is R into root S11. Square units. Area of the quadrilateral OAPB. OAPB. Whose area is how much? R into root S11 square units. Next, let us go to how to determine equation of the tangent. Okay, right? You know, this is circle whose equation is x square plus y square plus 2gx plus 2fy plus c equal to 0. Now, otherwise they may give x square plus y square equal to r square. Okay, see here one point on the circle is given. Actually infinitely many points are there. At every point you can able to draw one tangent. Now one of the point is given x1 comma y1. Now where you have to draw the tangent, whose equation we want. How do you do? Okay, differentiate this circle equation and substitute this point so that you will get dy by dx. Differentiate this circle equation with respect to x so that you will get dy by dx. So in that substitute this point so that you will get slope of the tangent. And after getting that slope, use that slope and use this point and apply point slope form. Y minus y1 is equal to m into x minus x1. This is one way of finding the equation of the tangent. What do you do? Differentiate this circle equation with respect to x and substitute this point. On substituting this point over there, what do you get? Slope of this tangent. That is m. And point is given. Apply this point slope form so that you will get equation of this tangent. This is one way. And one more way, okay, s1 equal to 0. I think this is easiest method. How it will come s1 equal to 0 means procedure is there. But no need to learn that derivation. Just remember like a standard result. X1 plus y1 plus g of x plus x1 plus f of y plus y1 plus e equal to 0. S1 equal to 0. Okay. Otherwise, so you can do like this also. This point of contact is given now. X1 comma y1. So identify the center. Minus g comma minus f you will get. So this is radius which makes 90 degrees with this tangent. Okay now. Now find whose slope. That is b m1 and find this tangent slope m2. So if you know here it is given and center you can find. So when you know the 2 points you can able to find m1 slope of this radius. And this makes 90 degrees with this. Obviously by applying m1 into m2 equal to minus 1 you will get tangent slope. So apply point slope form after getting slope of the tangent. Right. Next, same equation of this tangent you can find by parametric form also. Same procedure. Wherever x1, y1 is there, there you have to write r cos theta, r sin theta. If the center of the circle is 0, 0. the center of the circle is other than 0, you know the parametric form. H plus r cos theta comma k plus r sin theta. Okay na? So what is the equation of the tangent? S1 equal to 0. In that wherever x1, y1 is there, substitute that parametric form of a point so that you will get equation of the tangent in terms of that theta. Okay? Right. Next. So suppose, see here, if write the condition for a line y equal to mx plus c is a tangent of x square plus y square equal to r square. What is y equal to mx plus c is a tangent of x square plus y square equal to r square. Now this is y equal to mx plus c. Right. How do you do this? Okay, what they are asking? They are asking us to find, they are asking us to write a condition for this line to be a tangent of this circle. Okay, so here, before that, here I am telling you one point. Okay, listen carefully. One circle, one line is given. On the plane, how many ways can you draw? One line, one circle is given. How many ways can we draw on the plane? Means either we may get line and circle like this, or line and circle we may get like this, line and circle we may get like this. There is no relation between these two. Here this line is intersecting the circle at two distinct points. Hence this is called secant of this circle. This line is touching the circle at only one point. Hence it is called a tangent. Okay, Amma? Right. Now you will get circle equation, you will get line equation like this: ax plus by plus c equal to 0. Okay, circle equation is equal to 0 you will get. What do you people have to do? So here, identify the center O and find the perpendicular distance from center to this line, that is D, and the radius of the circle R. If D is more than R, no relation. Here, this is D. Now this is radius. If D is smaller than R, then that line be a secant. If D means perpendicular distance from center to this line, R means radius. If D is equal to R, then this line is a tangent for this circle. Okay? Right, next. Okay, here one more procedure is there. Okay, see here, circle equation will be given to you like this, and line equation will be given to like this. So here circle is having two variables x and y, and here also. So replace this y by this summa. One line equation, one circle equation is given, and from the line equation make y as subject. This y value substitute in the circle equation and simplify. You will get one quadratic equation in terms of x. For that quadratic equation, if delta is greater than 0, then that line will be the secant for the circle. If the discriminant value of the quadratic equation is 0, then that line is a tangent of the circle. If the discriminant value is less than 0, there is no relation between the circle and the line. Okay? Right here. To write that condition for this line to be a tangent of this circle, now I would like to use that r equal to d condition. Okay. Now what is the center of the circle? 0, 0. Now express this one in standard form: mx minus y plus c equal to 0. Now find the perpendicular distance from D center to this line. D is equal to mod of ax1. A means m. x1 0. 0 plus 0 plus c by root a square. A square means x coefficient m square plus y square minus 1. Minus 1 whole square 1. Now simplify. R equal to D now. Replace R by D. Now D is equal to c by root m square plus 1. Now when you take this one left side, okay, actually here mod is there. When you open the mod, here you have to take plus or minus. Now c is equal to, so plus or minus r into root of m square plus 1. Okay, so this is the condition for this line to be a tangent of this circle. What is that? C is equal to plus or minus r into root m square plus 1. Now replace that C by this condition. What is that line? This is a circle, no? From exterior point P. So you can draw one tangent this side and one more tangent this side. Okay, one is touching it here A, here at B. Now circle equation is x square plus y square equal to r square. Okay, what condition here? What is this tangent equation? Y equal to mx plus c. What condition have we got? C is equal to plus or minus r into root of m square plus 1. So now in the place of c, write that value. Now y equal to mx plus or minus r into root m square plus 1. When you take plus, you will get one tangent equation. When you take here minus, you will get one more tangent equation. So this is called slope form of the tangent. What do we say this one? Slope form of the tangent. When you take plus, you will get one tangent equation. When you take minus, you will get one more tangent equation. Okay. Now in the next step, so take mx to the left side. Y minus mx. So which is equal to plus or minus r into root of m square plus 1. Now square on both sides. Square on both sides. If you take square on both sides, what do we get? So here y square plus m square x square minus 2m xy. So which is equal to r into m square plus 1. So this tangent is passing through the point x1 y1, no? In the previous figure, tangent is passing through the point p x1 comma y1, from where we have drawn the tangents. So that, okay, here in this equation I am replacing xy by x1 y1. So that here you will get y1 square m square x square minus 2m x1 y1, which is equal to r square m square plus r square. Now bring all of them to the left side. First write okay, x here, x term m square term, m square x1 square. Next here minus, see here, when you bring this one left side, when you take m square common, here inside what do we get? x1 square minus r square. Here minus 2m x1 y1. Here y1 square minus r square is equal to 0. What is this? It is a one quadratic equation in terms of m, because x1 y1 is a one fixed point from where we have drawn the tangents in the previous diagram. Okay, so now we have got one quadratic equation in terms of m. Okay, now solve this. On solving this quadratic equation, we will get two values for m. One is taken as m1, other is taken as m2. Now my question is, what is the sum of their slopes? You know, sum of the slopes is equal to sum of the roots of a quadratic equation minus b by a, no? Minus, here b value minus 2x1 y1 by a. A means x1 square minus r square. Minus into minus plus. So here 2x1 y1 by x1 square minus r square is the sum of the slopes of the tangents drawn from x1 comma y1 to the circle. Next, product of the slopes m1 into m2 is equal to c by a. You know, product of the roots, c by a. C means here in the place of c, y1 square minus r square by here x1 square minus r square is there. Okay, now this one we will get for the product of the slopes of the two tangents drawn from x1 comma y1 to that circle. Y1 square minus r square by x1 square minus r square. Suppose if the angle between the tangents is 90 degrees. if these two tangents are perpendicular. If the two tangents are perpendicular, then the product of their slopes is equal to minus 1. Write m1 m2 equal to minus 1. If you write m1 into m2 equal to minus 1, so minus 1 is equal to y1 square minus r square by x1 square minus r square. Simplify. Minus x1 square plus r square, y1 square minus r square. Now if you simplify, what do we get? So here x1 square plus y1 square, which is equal to 2r square. But on the circle there are infinitely many tangents. Okay. But some of the tangents will intersect 90 degrees to each other outside. How many will they intersect? Means some, not all. Some tangents will intersect 90 degrees to each other outside. So hence that will be one locus. Okay, group of points. So where tangents will intersect 90 degrees to each other. So that locus is called a director circle. Okay, what is director circle? That is a locus where tangents are intersecting perpendicularly. Okay, if you replace this x1 y1 by x comma y, then you will get x square plus y square equal to 2r square. Is called equation of director circle. Director circle. Director circle is a circle where the tangents are intersecting perpendicularly. Okay, how it is derived, I hope you have understood. Now, I am asking you to write locus. Okay, locus of points where the tangents are intersecting, where the tangents are making an angle theta. See, this is the circle. On the circle, infinitely many tangents you can draw. But I want the locus where the angle between the tangents is theta. Like theta. So here, some more tangents may make an angle theta. Here, one more pair will make an angle theta. Here, one more pair will make an angle theta. So if you connect all these point of intersections, you will get a circle only. Okay, find that locus. Means, so you know this tan theta is equal to tan theta by 2 is equal to r by root s11. Okay, so by using that relation I am going to find this locus equation. See here, this is a circle. Okay, s equal to 0. No, this is the angle. So you know this is radius, this is root s11. Let us take this locus point as x1 comma y1. Okay, right. Suppose if you take the circle equation x square plus y square equal to r square, otherwise you can take locus point as h comma k. Now here tan theta by 2. Radius of this circle is r only. By root s11 h square plus k square minus r square. Now squaring on both sides and simplify. X square plus h square plus k square minus r square and send it to the right side. R square into cot square theta by 2 you will get. Okay. Now h square plus k square minus r square. Now r square into cot square theta by 2 can be written as cosec square theta by 2 minus 1. Now simplify this. If you simplify this, you will get h square plus k square minus r square. Now multiply these two terms with r square. R square cosec square theta by 2 minus r square. This minus r square cancel. Replace this locus point by xy. X square plus y square, which is equal to r square cosec square by 2. So this is the required locus of points where the tangents are intersecting an angle theta. Right. Next, let us go to the equation of normal of a circle. So here, suppose if the circle equation is given like this, x square plus y square equal to r square, one point is given. So where we have to find equation of the normal to this circle. Actually, what is this tangent? What we want? Normal. Normal means it is a perpendicular line, okay, to this tangent at its point of contact. Observe that in the circles, normal passes through the center of the circle. Normal passes through the center of the circle. Already point of contact is given and equation of the circle is given. If the equation of the circle is given, how to determine their centers you know. Center is known to you, point of contact is given. On the normal, 2 points are given now. When the 2 points are given, how to determine the equation of the line you know. Y minus y1 is equal to y2 minus y1 by x2 minus x1 of x minus x1. Use this formula and determine the equation of normal in Cartesian form as well as parametric form. In the parametric form, just in the place of x1 y1, you have to write r cos theta, r sin theta. Okay? Right. If the circle equation is given as x square plus y square plus 2gx plus 2fy plus c equal to 0, find the center. Minus g comma minus f. Point of contact is given. Again apply the same formula for Cartesian form of a normal. If it is asked in parametric form, replace that x1 y1 by h plus r cos theta comma k plus r sin theta and go for simplification so that you will get normal equation. Okay. Next, let us go to right. Next, let us go to pole and polar. Okay, circle is equal to 0. Next, pole polar concept, and before that, now I would like to discuss with you one thing. So sometimes, okay, here tangent equation will be given to you, y equal to mx plus c, and circle equation will be given to you, and they will ask you to find this point of contact also. How do you find this point of contact? How do you find this point of contact? So, point of contact is the put of the center on this line. This is 0, 0. Now write this tangent equation in standard form mx minus 5 plus c equal to 0. Now find whose put. So to find the put, we have one theorem called put of the perpendicular, h minus x1 by a, which is equal to k minus y1 by b. So minus of ax1 plus by1 plus c by a square plus b square. Now here, let us consider put b h comma k. Now in the place of x1 y1, write 0, 0, and in the place of a here, h by a means x coefficient here m, k by x1 y1 0, 0, b means here y coefficient minus 1, which is equal to this becomes 0, 0, c value c only, minus c by a square plus b square. Now take m right side. Now h is equal to minus mc by a square plus b square. Similarly, k is equal to minus into minus plus c by a square plus b square. So this is the put of this, means point of contact. Okay, I hope you have understood how to determine the point of contact of this tangent and this circle. Okay, what did I do here? I calculated the center and I calculated the put of this center on this line. So suppose if the line is given like this, Lx plus My plus N equal to 0. Sometimes every time a line equation will not be given as y equal to mx plus c. They may give lx plus my plus n equal to 0. So in this case, same. If you want that condition of this line to be a tangent of this, use r equal to d condition. R means radius of the circle. D means perpendicular distance from origin to this line. R only, perpendicular distance. So mod n by root L square plus m square. Now simplify this. This is the condition. Okay na? When you square on both sides, so here r square into L square plus m square, which is equal to n square, is the condition for this line to be a tangent of this. So suppose if you want the point of contact, same again, what you people have to do? What you people have to do? So find the put of this point on this line. So here h by a means L. So k by b means m. Now which is equal to, this becomes 0. Here minus c means minus n by L square plus m square. Okay. So now we equate these two. Now h is equal to minus nl by L square plus m square. And equate these two. K is equal to minus mn by L square plus m square. Okay? Right. Next, pole and polar concept. Okay? Okay, see that. Polar and pole of a circle. Now, here, this is one circle. Okay, what is polar? It is a one locus, okay, which is formed by point of intersection of tangents drawn at chords passing through a point P. What is polar? It is a one locus formed by point of intersection of tangents drawn at endpoints of the chords passing through a point P. See here, one point P is there. So many chords are passing through P and intersecting the circle at two distinct points where I am drawing the tangents. At endpoints of these chords, what I am doing? I am taking the tangents. Where I have taken these tangents, endpoints of these chords. So these tangents are intersecting some places. All these points are collinear. All these points are collinear. Okay. So this is called polar. This line is called polar of this point. This P will be called polar of this polar. Understood? This line is called polar of this P. P will be called pole of this polar. Okay? Right. So sometimes this pole, okay, if P is there on the circle, then whose polar will be the tangent drawn to the circle at P only. So suppose if P is there inside, then you will get polar will be outside. Suppose if P is coincides with the center of the circle, then polar of the center of a circle does not exist. Remember that point. Next. See, there are one point P is here, one point Q is here. Polar of P is passing through Q, polar of Q passing through P. Then P and Q are called conjugate points and these two polars are called conjugate lines. So when do you say P and Q are conjugate points? Whenever whose polars are passing through P and Q. Polar of P passes through Q, polar of Q passes through P. Then P and Q are called conjugate points and the two lines are called conjugate lines. Next, suppose here the circle equation is given, s equal to 0. Point is given, whose coordinates x1 comma y1. Now find the polar of P with respect to this circle means you have to apply this formula s1 equal to 0 only to get the equation of the polar. Okay. So sometimes polar equation will be given to you, circle equation will be given to you. They will ask you to find pole. Okay. What is given to you? Circle equation. X square plus y square equal to r square. Here point P is given, whose coordinates are x1 comma y1. Okay. And what is given to us? Pole. Polar is given. Polar is given, circle equation is given, asking us to find pole. Okay, I assumed the pole as x1, y1. So, what is the polar formula? S1 equal to 0. So, x1 plus y1 minus r square equal to 0. This is obtained by applying this formula, but it is given in the circle equation. Sorry, in the problem, Lx plus my plus n equal to 0. Both are representing same line equation, hence whose coefficients will be proportional. Now we equate, so x1 by L, so now which is equal to y1 by m, now which is equal to minus r square by n. Equate these two, so that you will get x1 comma y1 as, so minus r square L by n minus r square m by n. We got the pole. Okay, but if the circle equation is sometimes given as like this, x square plus y square plus 2gx plus 2fy plus c equal to 0. If the circle equation is given like this, then whose pole will be c minus g plus, so here minus, no, here plus will come, r square L by L. So here that polar is Lx plus my plus n equal to 0 now. So in the place of x and y, substitute the center minus g minus f and simplify. You will get Lg plus mf minus n. So which is equal to minus f plus r square m by same here Lg plus mf plus n. This is also called pole of this circle with respect, pole of this polar with respect to this circle. Okay, no confusion. When the circle center is origin, you will get this one as pole of this polar. The circle center is other than origin, this will be the pole of this polar with respect to this circle. Okay, now one circle equation is given like this, x square plus y square equal to r square. Now two polars are given, L1x plus M1y plus N1 equal to 0 and one more L2x plus M2y plus N2 equal to 0. They are saying that these two are conjugate lines with respect to this circle. Then you will get this condition, r square into L1 L2 plus M1 M2 which is equal to N1 N2. Okay, if these two are conjugate to with respect to this circle, then you will get this condition. How you have to derive this condition? Find the pole of this first polar with respect to this. You will get minus r square L1 by N1 minus r square M1 by N1. So substitute this value in the second line and simplify. You will get this r square L1 L2 plus M1 M2 is equal to N1 N2. So suppose if the circle equation is given like this, x square plus y square plus 2gx plus 2fy plus e equal to 0. Now in that case, what condition do we get? Okay, circle equation is given as x square plus y square plus 2gx plus 2fy plus e equal to 0, and that polar equations will be given as L1x plus M1y plus N1 equal to 0 and L2x plus M2y plus N2 equal to 0. Then what condition do we get? Here R square. R square means find the radius of the given circle. R square means g square plus f square minus c you will get into L1 L2 plus M1 M2 is equal to here Lg plus M F minus N1 into Lg plus Mf minus N2. So here L1 M1 L2 M2. Okay, right. Next, let us go to the inverse point of a circle S equal to 0. Inverse points S equal to 0. This is the center of a circle, and there are 2 points P and Q are called inverse points with respect to this circle. When these 2 points are inverse points with respect to this circle means C comma P comma Q must be collinear, and P and Q should be same side of C. P and Q should be same side of center, same side of C, either this side or this side. Next, third one, CP into CQ. CP into CQ is equal to small r square. Small r means radius of this circle. So these 2 points are called inverse points whenever these 2 points satisfies these 3 conditions. Okay, right. And also observe here. Okay, this Q will be the put of either C or P on polar of P. If you find polar of P which passes through Q, if you find the polar of P which passes through Q, suppose if you would have to calculate Q, then what you have to determine? First to find the polar of P. You will get this line equation and find the put of either C or P. So find put of P or C. So you will get Q coordinates. Next, let us see some locus applications related to the chord of a circle. See, circle is given. Now I want the locus of the chords which makes theta angle at the center. What I want? Find the locus of midpoints of chords which makes theta angle at the center. Here, like many more chords which may make same angle at the center. Here, suppose if you take this chord, it is making an angle theta here. This is one chord which is making an angle theta at the center. This is a chord which is making same angle at the center. But we want whose midpoints locus. Means if you connect all of them, you will get a circle which is concentric with the given circle. Find whose equation. How do you find? See here, this is circle. Okay, center, chord AB, making an angle theta. Now find point P. This is locus point. Take H comma K. Now draw here. It is making an angle theta. No, if you drop a perpendicular, this is theta by 2. Now this is radius of the circle. Circle equation will be given to x square plus y square equal to r square. Now circle center 0, 0. Okay? Right. Now define cos theta by 2. Cos theta by 2 in this figure. Total angle is theta, but I dropped the perpendicular and it is theta by 2, theta by 2. So define cos theta by 2. Adjacent by hypotenuse. Adjacent length is root h square plus k square by r. Now square on both sides. So you will get h square plus r square is equal to r square cos square theta by 2. Now replace hk by xy. X square plus y square is equal to r square cos square theta by 2 is the required locus of midpoints of chords which makes an angle theta at the center. What is this locus? Midpoints of chords which makes an angle theta at the center. And here students remember one more point. This is circle equation, and this is chord AB, and see radius r is given. Okay, so suppose chord equation is given. When chord equation is given, circle equation is given, you can able to find radius and you can able to find this d. D means perpendicular distance from center to this chord. Now this will be the midpoint. If you drop a perpendicular from center to the chord, it will meet midpoint of AB. Now apply the Pythagoras theorem. AP will be root of r square minus d square. And if you want AB, what you have to do? You have to take double of this. AP is equal to PB. Hence AB length will be 2 into root r square minus d square is the length of the chord. Okay? Right. So sometimes see, this is chord. Chord extreme points will be given to you. So x1 comma y1 1 point and x2 comma y2 1 point. And they will ask you to find this chord equation. So you people have to this formula to find this chord equation. S1 plus S2 is equal to S12. Otherwise, you know the 2 points on this chord. Apply the 2 points form of a line equation. So sometimes they will give you circle equation and they will give you midpoint of chord x1 comma y1, and they will ask you to find this chord length. So you people have to apply this formula to find the length of this chord. 2 into root of mod S11 square units. Length of the chord AB when midpoint of P is given. Because here you will get negative. So that I used the mod symbol. Because length it should be positive. Okay. So that too square root symbol is given. So inside it should be positive. So that I used the mod symbol. Okay. Right. Next. Circle equation is given. Midpoint of the chord is given. And they will ask you to find chord equation AB. Equation of AB. Okay. Apply this formula. S1 is equal to S11. You will get this chord equation if you apply this formula. S1 equal to S11. Otherwise, find the center, get this slope M1 and find whose perpendicular slope M2, and you know the point, you know the slope. Apply the point slope form so that you will get AB equation. Now next, find the locus of a chord which moves k units away from the center of this circle. X square plus y square equal to r square. We want a chord equation which is how much far away from center? K units. Very easy, no? Center 0, 0 and this is the locus. Okay. This chord equation we want. So this chord is moving locus of chord which is moving k units away from the center means this locus point you have to take. So some p comma q you take. Now find the distance between them. p square plus q square, which is equal to this length is given in the problem as k. Now square on both sides. Now replace p and q by xy. X square plus y square equal to k square. What is this? Equation of locus of a chord which is maintaining k units from the center of the circle. Equation of locus of the chord which is moving k units away from the center of this circle. Right? Next. Right. Relative positions of circles. Okay. And also common tangents concept. Next I am going to discuss with you common tangents. See, observe these two circles. For these two circles, what is this? Common tangent. It is a tangent of first circle as well as second circle. And see, observe these two circles. So, these two circles are lying same side of this tangent. Okay? Hence, this common tangent is called direct common tangent. Here observe these two circles. Both circles are lying either side of this tangent. Hence it is called transverse common tangent. Transverse common tangent. This is called direct common tangent. So, see, now I am asking you to draw two circles on the plane. How many ways can you draw? See here. These are called non-intersecting circles. These are called intersecting circles. These are called circles touching externally. These are called circles touching internally. These are called, one circle is completely lying in other. These are called concentric circles. This means ways you can draw two circles on the plane. So here two circle equations are given. So you people can't able to draw whose diagram on the plane, but you can tell what kind of figure do you get. How means there is a procedure. See here, two circle equations will be given to you. S1 equal to 0, S2 equal to 0. Identify their centers C1 and C2. Measure the distance between their centers and find the radius of first circle and find the radius of second circle. So if you get D is more than R1 plus R2, then you will get non-intersecting circles. Okay? Two circle equations are given. Find the center of first circle, find the center of second circle, measure the distance. And if you observe D is more than R1 plus R2, circles will be non-intersecting. In that case, you will get two direct common tangents, two transverse common tangents. For total, 4 common tangents you will get. So, for this intersecting circles, this will be the condition. Mod R less than R2 less than D less than R1 plus R2. If you find this relation, the circles will be intersecting. So, two direct common tangents are possible. So, in this case, D is equal to R1 plus R2. Two direct, one transverse. In this case, D is equal to mod of R1 minus R2. Okay? So, let us take a big radius as R1, small radius as R2. So, if you find this relation, only one common tangent is possible, that is direct common tangent. In this case, your D is smaller than mod of R1 minus R2. If you find this relation, one circle is completely lying in other, so you cannot able to find common tangents for this. Here for concentric circles also, common tangents are not possible. Okay, so this concept is called relative positions of circles. And See, sometimes they will ask you to find length of direct common tangent and length of transverse common tangent. Okay, see here, this is one circle and this is one more circle. So we want this direct common tangent. How do you find? First you have to find the centers and you have to measure their distance D. Find the radius of bigger circle. Let it be R1. This is R2. Now you want this direct common tangent A to B. Okay. Now draw one construction. Draw a circle which is concentric with this circle whose radius is equal to R2. This dotted circle radius is R2, but I want this length. How much? R1 minus R2. Now draw this. Now here it is making an angle 90. Okay. So this length equal to this length D. This is R1 minus R2. So I want this. So here it is a one right angle triangle. Apply the Pythagoras theorem. Here D square is the hypotenuse which is equal to AB square plus R1 minus R2 whole square. Now bring it to the left side. Now AB square which correct only. D square minus R1 minus R2 whole square. Now send the square to the right side so that you will get square root of D square minus R1 minus R2 whole square units. This is the length of the tangent, direct common tangent. For transverse common tangent you will get plus middle. Okay. So here this is transverse common tangent length. Okay. Whose length formula is root of D square. Here middle plus will come. R1 plus R2 whole square units. Right. Next, let us go to the centers of similitude. See, this is one circle, this is one more circle. So here it is one direct common tangent, it is one direct common tangent. Both are intersecting at one point. That is called external center of similitude. External center of similitude. So you can take represent this one with A, and this one is called point of intersection of transverse common tangent. This one is called internal center of similitude. Internal center of similitude. Okay, and this is center of first circle, this is center of second circle. This C1 internal similitude, let us represent with B. C1, B, C2 and A all will be collinear. And this B divides C1, C2 in the ratio of R1 is to R2. B divides C1, C2 in the ratio of R1 is to R2. A divides C1, C2 in the ratio of minus R1 is to R2. Where R1 is the radius of first circle, R2 is the radius of second circle. Okay. So this is a complete concept related to this IIT G and advanced syllabus. Thank you.